All right, we got a fun one here. What we're going to do is we're actually going to interpret our information that we've been looking at in our last few videos from a graph, only from a graph. So let's just dive right in. So the first thing is we're going to look at the critical numbers for f of x. So what are those critical points that we would have gotten from the first derivative? So remember, critical points happen when the derivative doesn't exist or it equals 0. So if we look at our graph here, our graph is our derivative. So where does my derivative equal 0? Well, that's going to happen here at 2, 4, and 8. So my critical numbers are at 2, 4, and 8. And again, that's happening because my derivative equals 0. Okay, so our next piece is where is f of x increasing? So remember, f of x is increasing when your derivative is positive. Your derivative is positive when it's above the x-axis. So that means it's going to be increasing from 2 to 4. That's where it's above the x-axis. At 4, it's 0, so it's not above or below, right? So my first interval is from 2 to 4, and then it's above the x-axis from 4 to 8. Make sense? Where the derivative is positive, it's above the x-axis. Where is f of x decreasing? F of x is decreasing when your derivative is negative, so less than 0. So that means we're going to be from negative infinity to 2, and then from 8 to infinity. Does that make sense? Hope so. If not, let me know. Okay, the next question is, where or if do I have a local maximum? If you remember, a local maximum happens when our derivative changes from an increase to a decrease. So where does my derivative change from increasing to decreasing? That's going to happen here at 8, because we have a positive derivative above the x-axis, and then it goes below the x-axis to a negative derivative, increase to a decrease. So we have a local max when x equals 8. Same question, what about a local minimum? Minimums happen when we change from a decrease to an increase. So when we change from a negative derivative to a positive derivative. So we're going to see a local minimum at x equals 2. Just for conversation, if we look at 4, it goes from an increase to an increase. So what's happening there on f of x is we're seeing something like this, where it's increasing, hits the slope of 0, and then it increases again. That's not a maximum or a minimum. We call that a terrace point. Okay, moving forward. When is f of x concave up? Concave up happens when the second derivative is positive. If I'm looking at the first derivative, but I need to think about the second derivative, we're going to look at the slope of f prime. So where is f prime increasing? Well, it's increasing from negative infinity to about 3. So it's concave up from negative infinity to 3. And then it's also increasing from 4 to 6. So we're going to see concave up from 4 to 6. We'll see concave down when f prime is decreasing, meaning the second derivative is negative. So that's going to happen from 3 to 4, and then from 6 to infinity. Does that make sense? I hope. Okay, and where would we find inflection points? Inflection points change or show up when we see a change in concavity, which means we're going to look for where f prime changes from an increase to a decrease, or decrease to an increase, right? So here it's increasing, changes to a decrease. So we're going to have a point of inflection at 3, and then we decrease. Here it's going to change to an increase, so we're going to see a change at 4, which means there's a point of inflection, and then increase to a decrease, That's going to happen again at 6. So there's a lot of information given from one graph. We know a lot about f of x, and we know a lot about f double prime of x. So things to look at, making sure we understand how all of these work together. Good luck.